Tears edition. Oh, leftist tears edition. Yes. Well, I just got one through what was it? Cub Cadet fanatics or knuckleheads or something like that, because that's where I go once in a while. And the guy was asking about his generator. Put in a new regulator, polarize the generator, can't get it to charge. And it hit me that there's several things that go on here. And I tried to describe it to him in words, but I figured I'd come over here and see. I mean, nobody's going to come on by the time I'm done. It isn't going to be that long. However, you're talking about Cub Cadets with old K series Kohler engines. How this, however, works for Briggs and Stratton. I don't think I've ever seen this stuff on Tecumseh, but I have on Wisconsin, Tecumseh. Yeah, Wisconsin, Tecumseh, Briggs and Stratton, and specifically Kohler, because a lot of their engines were in the lawn tractors of years past. But a lot of Briggs and Stratton too. In fact, I've seen vertical shaft Briggs and Strattons with a starter generator on it. Excuse me. So the rare deal, but I have seen it a couple times. Now, what's the test? Everyone that I've seen is Delco Remy, so we're going to start there. Delco Remy is a, how can I say it? The basic rotating core, the armature, is the same basic brushes as they all do, and it's kind of a carbon copper combination brush because it's a starter and generator. But when it comes to the field, there are two different types of fields, and I'm only going to talk about the Delco style, which takes a wire, connects it into the output of the armature circuit, as I remember, and runs it through the fields and then grounds externally. Now, that's why it's important that these things are polarized. The other is the reverse, but don't go there. So we have two posts on there. One is armature, the other is field. That's it. Armature and field, two posts. Armature is the output, okay, going back to the battery, but it's also starter input. That's why there's a big heavy wire on there, usually in the neighborhood of a number 2, 4, or 4, sometimes as small as an 8. But usually it's someplace around a 4, and occasionally you'll see a 6. But it's really not, the thing's 15 amp charge. The main reason it's big is for start, because under start conditions, the sucker over 50, 60 amps can roll through there, because it's an inefficient starter system, but it's simple. And it's obviously bulky. So when you turn the key, juice goes into the armature terminal. Beautiful. Nothing's charging, so the regulator isn't even turned on yet. It's saying, no, not me, not today. So you're cranking and whirling the thing over. Well, while that's having a grand old time, whirling over, now it fires up. When it starts up, there's no juice going there. So now juice can come out of there. That's where the polarization comes in. It starts out producing electricity internally. Now, when it does, it backfeeds, and the regulator has a wire from the hot feed to usually the armature. Sometimes it'll be labeled gen, coming out of the regulator, but it usually comes off the starter post on the starter side, and then it'll go to the regulator. Inside that regulator, it first goes to cutout relay. Cutout relay is normally open. Now, once the generator produces the appropriate set amount, which is usually in the neighborhood of 12.5 to 13 volts, then that closes. When the cutout relay closes, now it goes over to the other one, which is a combination unit. It's both amps and voltage regulator. Those contacts are closed. They don't open until they reach the peak voltage that they're set at. Now, starter generators, any generator system, 12 volt is generally around 13.5 volts. Sometimes they'll turn them up as high as 14. It's just something, a slight difference that I've seen over the years. Generator systems, they run about 1 volt lower than alternator systems. Don't know why? Don't care. I think part of it is generator is pure DC. So what it does at 13.5 volts is equivalent to what an alternator does with its rapidly changing pulses on its 3 cycles that come out of there, 3 waves. It does at 14 to 14.5 volts. So that's kind of a different deal there. And the battery doesn't seem to care about either, but it usually lasts. Batteries last longer with generator systems. That's all there is to it. They do. I don't know why. I don't know what the deal is, but the other part of it is the systems also are not called on with such a how can I say it? Starting force. The regular, actual, dedicated starter draws far more amps and works far better than the starter generator. So I think that's another reason that they turn it up to 14 and a half to get that battery charge back up. But at the same time, starter generator. So now you've got it running. You've cranked it over, juice going in. You've got it running. This polarization works. It starts producing voltage. Voltage feeds back, closes the cutout relay, because you still don't have any amps flowing. This is just, there's only a little bit of amperage going through it, just enough to tickle that cutout relay, reaches the voltage, it closes. Now the gap is pretty much what your setting is. There are two air gaps on the cutout relay. There's the air gap for the points, but there's also the air gap at the coil. So both of them have to be within a specific amount so that it will close. Now the one tab above the points usually sets both, but sometimes things get bent and then it's not the same. So you end up with two adjustments there when you're fumbling with it. Cutout relay closed. Okay, now the generator is connected to the battery. If everything goes well, it starts charging. Go to the next set that's closed. The voltage amp limiter, or yeah, basically your voltage amp control. So when that reaches a peak volts, then that opens, and then it starts rattling to control your maximum voltage. But also, if it really gets high amp flow, there are two sets of windings on there. One is heavy for the amp, and the other is fine for the voltage. And when the amps reach a certain amount, because the fine is connected to a ground, just to run voltage through it. That's it. But even that doesn't work until the cutout relay is closed. So you'll find all kinds of fine wires in there that you can break and ruin the regulator if you're screwing around in there. But the heavy winding is the actual charging winding going to the battery. So that's a whole nother deal there. And that one is from the cutout relay, the juice coming in, going through, and going out to charge the battery to the B terminal, etc. Now, you've got those two, and this one doesn't have an air gap so much as there's an air gap back here by the coil. So you set that with moving your 2 points, but mainly what you're doing is you'll set a maximum that these points can be open, but usually that maximum is set by your voltage. The spring on the back. The spring on the back of both of them controls when the volts close the cutout relay, and the voltage control also. So, and it's a very fine adjustment. So if it doesn't work when it's new, you're better off getting another one. But let's say you're adventurous here, okay? And something isn't working within this system. What have we got to do for testing? Well, the first thing you can do is go back to the starter generator. Your engine's off. Go back to the starter generator and take the field winding off, the light wire. Take that one off. Put it out of the way. And start the unit up. Starts up, your generator's working. You know it's generally polarized now because it's starting. It has to be. But at the same time, that's not 100% certain on whether it's charging or not. While the unit's running, you've got a voltmeter hooked up, and it just sits there at battery voltage. Take a ground wire from the field terminal, not the A terminal, the field, the F terminal, the light wire you just took off. That goes back to the F terminal of the regulator for field. Well, you've got it disconnected at the starter generator. Put a ground clip on there, test lead. You don't want a real light one either, not some little, but you want something, you don't need a real heavy wire here. 16 gauge is fine. Ground it. What? Well, no. Internally, if everything's working properly, the juice goes through the field and then across to the other field and comes out the field post. With all those fine windings in the field, there's not much coming out of there but maybe a couple of amps. Usually 2 to 3 at the most. So you got 16 gauge wire, you're fine. Ground it. Your engine should grunt and your voltmeter should go up. Now don't leave it on any longer than half a minute to a minute. Why? For one main reason is the little buggers are what they call shunt wound. Now I don't know the specifics of the engineering behind it, but what shunt wound means is that if you disconnected the belt and motorized it with juice to the hot lead, the A terminal, and let it spin free by itself, it'll take a long time, but that thing will have almost infinite speed that it can attain, but it has no torque. So shunt wound is uncontrolled. The windings are set up to maximum RPM, but a controlled output, maximum output. So when it's charging, it can charge and keep right on charging 20. It usually doesn't go much over 20 volts because of the RPM when you're at full throttle. Now, if you're not at full throttle, you aren't going to have a problem with this. But it can reach 12, 13 volts long before half throttle. And that's what the control is on the regulator. Now you're running, you don't have the regulator, right? You are the regulator. You just put a jumper lead on there, and this puppy is either going to work, and make sure you have an excellent ground there. And if everything is working right, you can take a test light before you connect the lead, put a test light on that field terminal and just get it to light a little bit. If not, light very well. Hook up your ground lead, and you should hear the engine grunt, your voltage start climbing up on your battery. Not much of a problem there, is there? Okay, now in some of these units, the voltage regulators still won't close. Now, I've had to do on a few of them is occasionally, while it's running and the field terminal grounded, I will take a jumper lead from the A terminal and put it to the battery plus or hot post. That is assuming you haven't connected this thing backwards. The output terminal of the starter generator goes to the hot post plus post positive terminal. And just a momentary touch. And to give you an idea, well, there's sparks and grunts and tells you your starter generator is working. Now that jumper lead from the A terminal to the battery plus or hot side is now, you are now the cutout relay. You're the safety. Get my drift? There are two safeties here. One stays open until there's sufficient energy. You just bypassed it. The other one opens when there's sufficient energy. That's the other. One is a minimum, one is a maximum. So you need to be careful when you're farting around with this stuff, but that's how I test my starter generators. Generally, I can bypass everything right there and test it. Now, what do you say, leaving the regulator in the system? You probably can, but I just don't tend to do that because the voltage regulator side, things can go bad. It's fine wound. I just tend to stay away from that. So then you can't do much disconnect unless you take the regulator completely out and tape off the battery wire, the battery charging wire. You start getting into a whole nother batch of things there. But what I have done in the past for testing purposes is disconnected both wires and covered them. Used a jumper lead to crank the engine over and get it started. And while it's running, starter generator's naked by itself. Then use the two jumper wires, field to ground, and then the other wire to the battery. See if the bugger will charge. So that's a whole nother ball game, the way I've charged over the years. Every so often I have to test my Cub Cadet like that in the past, but lately, even with a China regulator, I haven't had much trouble. Now, if you're working, your starter generator is working fine. You've ascertained that the thing puts out 16 plus volts, which you need 15 to 16 maximum volts, or as a minimum voltage without the regulator involved, so that the regulator can have something to regulate. And you need to get up there pretty quick about half throttle, which RPM wise, you're talking on a Kohler, we'll say 2,000 to 3,600. So you're talking 1,600, you're talking around 25 to 2,800 RPM. I don't know how to test that. Well, I guess. You can use a vibration tach as well, but you know what half throttle is. You know what your full throttle is. You know what idle is. You get a feel for it. All right, so your starter generator's working, everything's fine. Now what? Well, like the guy that was on the Cub Cadet fans thing, what's he got? Well, he got a brand new regulator on there. Now what? Disconnect all the power. There's nothing. naked power, batteries disconnected, and covered so that the wires can't fall back on there. That's when bad things happen. Now, if you're adventurous, you take your regulator and it's in a bad spot, back in there by the battery. It's a mess. You can't do anything with it there to adjust or anything else. It's terrible. Now, you have to either take the battery out, disconnect it, and then connect it somewhere else, or use a jumper battery in place of the battery once you take the battery out. And the regulator you can take out to adjust and work with. However, if you can't adjust it in the tractor with the seat up, you're going to take it out, then you need to run a ground wire from the base of the unit to the battery. The unit will not work without a solid ground. And that is one of the problems that many people have, is grounding to the frame, so it'll start at the engine, but it's not grounded to the engine, to the frame, to the battery, all together. So there's quite, especially if you have an anti-vibe engine, or if you have poor mounts on the engine, quite often the ground lead goes to the engine, while the hot lead goes to the starter solenoid, and then on down to your starter generator. But that one ground lead on the engine, and if you got a problem down below with your engine mounting, it can just be dirty over the years even, and your bolts and such. Well, you need to get a ground lead from the engine to the frame to help take care of this problem. And in some cases, I've seen it, a wire run from either the engine or some good connection where the ground lead is and run it all the way back to the base of the regulator. In a factory, I have seen that occasionally on some units. Not necessarily just Cub Cadet, but quite often I've seen that on Cadet. So farm tractors as well. That ground is important because the voltage regulator does not work without a ground. The other one is the regulator is supposed to have a ground strap between the base and around the rubber mounting to the actual solid frame base so that the unit can work. And there's usually a braided line there. Well, sometimes that braided line doesn't work the way it's supposed to, or it broke, or pulled out, and I've seen all of the above. So those are the major things you can do with this. What about your regulator itself? Well, try not to adjust it or change any of the adjustments. You've got it out, you pop the top, you may or may not want to test it separate. You'll see the 2 points, the open points and the closed points. In each case, take the open points and a good, solid, firm piece of paper with no torn edges. Run it in and out of the points, okay, and then open them to take the paper out. Never slide the paper out of it fully out of a closed set of points, because at the edge you'll tear it off and you'll have paper between your points and you won't see it. It only takes a little bit. Screw it all up. And better yet, it'll burn and cause a carbon. Yeah, it's bad. On the other one, your voltage points. Run the paper gently through it. You might even have to hold those open slightly. But open it up, get the paper in there, move it back and forth enough to clean them off, open them, slide the paper out, double check to be sure there's nothing in there, and then test it again. If you're curious, make sure all of your power is off and run a voltmeter or ohm meter to test the resistance of the points. That's getting overkill. You usually can see it, but it's also another idea, just in case the China part came across and they put some of that preservative on the points, or slopped over and got on the points. Stuff happens in shipments. Why? Because both sets, cutout relay and voltage amp relay, are covered with chemicals to help prevent corrosion or anything else outside of them. And sometimes that stuff doesn't get on there right and drips off, makes a mess. Well, anyway, or if it's sat in a shelf too long, even though it's sealed semi, it'll still corrode. So be careful, put everything back together and test it. And like I said, if you have to test it separate, use a jumper box and also on the regulator side, be sure that base is grounded, because bad things can happen. So that's how I test your starter generator systems. Now, as a caveat, as people like to say, in other words, the second point to go along with this, when you're testing just simple generators on farm tractors and other units that have generators instead of alternators, as long as they're Delco Remy, the exact same testing can go on. Yes, it can. No doubt about it. You can hook a battery wire up to the armature terminal, and actually, if it's separate from all the rest of the system, your belt is off, hooking to that A terminal with a battery, and the unit grounded should start it motoring. Now take the field and ground it to the ground, And generally, sometimes it grunts, sometimes it speeds up, but you're just touching it and releasing it for about a 1001 and you're off. What's that for? That runs juice through your fields to get it polarized properly while you're on the bench. And sometimes on the machine you have to do the same thing. So just to give you some ideas what to do while you're working and fumbling around with this stuff. That's with a generator, the starter generator. As soon as you hook something up to the A terminal and start using it as a starter, it has to have an internal ground through the armature to make it work to begin with. So generally that field alone takes that magnetic field from the rotor, the armature, will take care of your field windings, but not necessarily. So just something else to keep in mind when you're working with this stuff. That's why quite often once I get it running, I'll hook direct to the battery hot and hook the field to the ground and see what the old girl does. So there you are. That's something. Be careful with your testing. High sparks, high amps, high volts. It doesn't matter. Your little lawn and garden battery has 180 cold cranking amps. Yeah, it does. You know what they forget to tell you on those batteries? You got 180 cold cranking amps, 300, 350, 345, 320, 310. I've seen all kinds of numbers, 260s, 285s. You know what they don't tell you is that for a brief millisecond, when you connect that can blow past 500 amps and scald anything on your body that's on bare metal in that. Now, the amps aren't going to do anything for you with 12 volts. Amperage kills. I know it's only 40 milliamps. Across your heart will stop it dead. And all you need is a shock across. Yeah, I've heard all that. I was an EMT in training, and I actually was trained to hit you with the paddles. Actually, they weren't paddles. They were little stickers on a little Marquette semi-automatic unit. So I'm familiar with that. But I want to tell you something that most people that get all excited and dramatic about that forget and don't know. Most of them are, fence post dumb ignorant. 12 volts is not enough in a 99.99999% of the cases to push any amount of milliamps across, even if you've got your hands on the terminals. 24 volts doesn't even often cause a problem with anybody, speaking from experience on 24 volts. Don't stick your tongue across it, you moron. It's not a simple 9-volt battery with milliamps. Anything 24 volts, consider 1,000 amps are there, and don't screw with it. But on 12 volts, it can still burn you, scald you, and the idea that it's going to shock you and kill you, you'd have to have a direct lead connected to your heart to cause any trouble. So let's just get that right out of the way. Even with 24 volts, the actual shock that you might get from some of this stuff, nothing. Now, another warning for some idiots that keep playing around with this stuff. Inside the regulator, you have those coils, correct? And if you start playing around with the coils and points and connections and all of that, just a warning. Solenoids, even little bitty teeny tiny relays, have little coils in them. You know, the Bosch type relays that you use for lighting and circuits and cars and other things. A lot of them have diodes near them. You know what the diode's for? Because it acts just like the coil on your old tractor or old farm tractor or your Cub Cadet. You can get shocked off that puppy. Yeah, same way as your car creates, or your Cub Cadet can create 20,000 volts when the point's open. Not when they close, when they open. The collapsing magnetic field spins a field around the wires because the wires interfere with it. And that's how they create the voltage and amps going through it. Tick, 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 tick. Oh, yeah. Anything that has a coil can blast you with 50 to 100 volts. Oh, it's pretty. Yeah. I've been tickled a few times. And that's not with an ignition coil. That's a control coil. Just in little relays, or as in this case, in a regulator. So if you get shocked once in a while, don't panic if you're an ignorant and aren't familiar with this stuff. All right? What's the possibility? Almost none. But somebody out there will be dumb enough to put their tongue across a couple terminals and fry their brain. Well, fry your tongue anyway. It's been done. And no kidding. I had an idiot. He was a teenager. Idiot neighbor. He had a black finger covered up. And said, what in the world's going on? He's running around like this. And he said, well, I wanted to see what would happen when I plugged the wire in the wall and stuck my finger between the terminals. Bang! There he was on the floor. Everybody's wondering what was going on, and he's on the floor going, Fortunately, he was on the upper floor. If he'd have been in the basement in the humidity, it probably would have killed him. Because then you'll get your 40 milliamps across the heart when you're grabbing hold of a hot wire and your knees are grounded on a concrete floor that's usually damp. Now you got a problem. Okay, that's your safety issue from Pops for the day. We're up at 25 minutes. You folks have a good day. And remember, take your time. And if you're not familiar with this stuff, write it down. Take pictures. And then write it down. For me, it's not that complicated. I've been doing this stuff for over 45 years. Okay? And that's what I remember. If I go to do it, ding, 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 it's done. You know, that's because you're something. No, it's not intelligence. It's just experience. Of course, I'm not an idiot, or I wouldn't remember this stuff. But still, played with it for a long time. Alternator conversions? Oh, man, you want to do one of those? You won't be doing it on your Cub Cadet. We'll talk about some of that stuff later. Time to go. See ya.